Similarity unit. Last thing is you're going to notice here when we do our first activity that if two figures are similar, there's a relationship between their perimeters and areas. All right. So what I want you to do right now, everyone turn to the second page of your notes. Everyone see the huge sheet of graph paper I've given you there. Okay, what I'd like you to do first, please, is make a 3x4 rectangle, please. A 3x4 rectangle. All right, on that graph paper, 3x4. And make sure you know, label it inside, draw an arrow to it, doesn't matter to me. Just make sure you know that's our original rectangle. All right, is the 3x4. And what I'd like you to do in your group by yourself real quick is please find the perimeter and the area of that rectangle. I don't think you need to really do much, but find the perimeter and the area. So what are the perimeter and the area of your original rectangle right now? 2, you're up. Original and perimeter and area, sorry. 14 units, yep. And how about the area? 12 units, length times width, right? Everyone good? Okay, now we're going to make some class decisions. What I want you to do now is make another rectangle, but it's got to be similar to the original, which means their length and width have to correspond with each other. So if the length is 3 times as big, so does the width has to be 3 times as big. If it's going to be half as big, the other side has to be half as big. So can we come up with, don't do your own yet, we're going to all do the same one here. Big decision here, 7, good job, way to go. 22. Ooh, 6x8, there's original, Madeline, huh? Double it. So everyone go ahead, 6x8. Now look, if you can do the perimeter in the area without drawing it in, that's fine. I don't expect you to draw it in if you don't want to. Okay. I'm really concerned about the perimeter in the area, please, of a 6x8 rectangle. Eight, when you're ready. Great, again. 6. 11. There's 3 for 3. 3 for 3. 23. Perimeter. How about the area? 48. All right. All right. 2 more times doing this. 2 more times. Give me another rectangle we're going to use that's similar. 11. Yep. 22. Another rectangle we're going to use. Ooh, wow. 12 by 16. There you go. Again, not needed to graph it. 12 by 16. Perimeter and area. Okay, perimeter and area for that one. Here you go. 12, perimeter and area. 192, and how about the perimeter? 60? 12, 12, 16, 16. What are we doing here? It's just 12 plus 12 plus 16 plus 16. One more rectangle so we can finally finish this here. 18, one more type of rectangle. What is it? 30 by 40, sure. I don't know if anybody wants to draw that one out. Good luck. And when you're ready, how about the perimeter and area when you're ready? 2, when you're ready. 1,200 perimeter. Oh, 140. All right, everyone good. That was fun. All right, let's figure out some patterns now. Everyone take your rectangle 1 and the original right now. Rectangle 1 to the original. The first thing I want to know is this similarity ratio, which we'll review again. That's the ratio of 2 corresponding sides. So if you take 1 to the original right now, so 6 to 3, 8 to 4, that's a ratio of 2 to 1. So my similarity ratio for rectangle 1 to the original is 2 to 1. I want you to do the same thing, but take their perimeters right now. What was the perimeter of rectangle 1? Perimeter of rectangle 1. 28. Perimeter of the original. 28 to 14. 28 to 14. That's a ratio of? Oh, shocking. Now let's do it for area. 48 to 12. 48 to 12. That reduces to what ratio here? 3? 4 to 1. There we go. All right, let's keep doing this 2 more times. Now everyone take number 2 to the original. What's my similarity ratio now from 2 to the original? 2 to the original. What do you have for me? 29, 2 to the original? 4 to 1? Everyone go perimeter now. 56 to 14. 56 to 14 reduces down to 26. 4 to 1. And then finally, how about 192 to 12? 192 to 12. What's that ratio break down to? 19? 16 to 1. I don't know if we're seeing any patterns yet. How the similarity ratio relates to the perimeter and the area ratio. Let's keep going 1 more. Now do 3 to the original. What's my similarity ratio there? 12. Similarity ratio? 30 to 3, 40 to 4. They all reduce down to what? 10 to 1, everybody. 10 to 1. What about 140 to 14? 4? 10 to 1. And then finally the areas, 1200 to 12. 13? Not here? Okay, thank you. 29? There you go, nice job. Here's what I'm going to ask you right now. If you know the similarity ratio, how does it compare to the perimeters? It's always the same. Always the same. If you know the similarity ratio of 2 similar figures, the perimeter ratio is the same, but not the case for the areas. But how can you get me to the areas? Nice job, square them. Yes, now let's write all this down here while we're on fire. Okay, so here's the theorem. Number 1, I'm going to go S1 over S2. The S stands for the similarity ratio. All right, that's the similarity ratio. That's the same ratio as, what did we just prove? 14. The similarity ratio is the same ratio as the perimeter. So perimeter 1 over perimeter 2. Those ratios are the same. P for perimeter ratio. All right, now, same thing. If you know the similarity ratio, was this true, that the areas had the same ratio? Is that true? No, somebody adjust this for me. How do I make this equal? I square the similarity ratio. Okay? And then A for area ratio. Only if they're similar. Only if they're similar. Plenty of time. Questions from you guys? All right, take a quick breath because I'm just going to go boom, 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 boom right around the room here for these next couple before we get to the last word problem. All right, here we go. Number one, those figures, I'm going to tell you in the directions, they're similar. Here's what I want from you. First thing, ratio of the perimeters. What ratio are the perimeters in? Well, let me ask somebody this question. 17. The perimeter ratio is same as the what today? Similarity ratio, which is two corresponding sides. Do we have that? What's the ratio of two corresponding sides? So that's the ratio of the perimeters, 4 to 5. Now, hey, get this through your mind right now. Am I saying the perimeter of the smaller one is 4 and the perimeter of the larger one is 5? No. What I'm saying is whatever the perimeters are, if you put them on top of each other reduced, guess what it would reduce down to? 4 over 5. All right, don't get in the mindset that, oh, perimeter of the smaller one is 4 and the larger one's 5. That's ridiculous in that problem. Obviously not. But whatever the perimeters are and you put them over on top of each other, it's going to be some ratio of 4 to 5. All right, not true for the areas, though. The area ratio will not be 4 to 5. What's the relationship? What do I have to do with that 4 over 5? 13? Oh, my fire's gone now. 14? Square them. So I'm going to do 4 squared over 5 squared. So the ratio of your areas is 16 and 25. Guys, am I saying that's what the area is? No. I'm just saying whatever the areas are, you put them on top of each other and reduce. It's some ratio 16 to 25. Everyone all good there? Now it's going to get slightly tougher for 2. Perimeter ratio. Same as the similarity. Ooh, but what 2 sides match up, huh? What 2 sides match up? Put the angles on top of each other. Put the congruent angles visually on top of each other, and you'll see which one matches up. The 3 would match up with, 7, you're on fire. 10, what's the 3 match up with? What do we think? 5? Yep, so that means that's the perimeter ratio, 3 to 5. Not the actual perimeters, just the ratio of them. And then going based off of that now, how about my area formulas? My area ratio. Similarity was 3 to 5. Area ratio, what do you got for me? 3? 3 squared over 5 squared, also known as 9 to 25. Everyone feeling all right here? Feeling all right? Because I'm going to ask you to go backwards now. Going to ask you to go backwards. All right, I got 2 hexagons that are similar. The areas are 8 to 32. What's the similarity ratio? So now I want you to actually go that way. Going this way now. Going that way. So if I have the areas as 8 over 32, what can I do to get to the similarity ratio? Remember how I got there? I want to undo it. Any idea on what I can do to 8 and 32? 3? Square root them. Nice job. So instead of squaring it, I'm going to take the square root of both. And I can do that on my calculator. So I'm getting a nice little fraction here, or parentheses if you don't have a fraction template. And I'm just going to put square root of 8 over the square root of 32. There's the similarity ratio. Hopefully you get 0.5 out, or a fraction of 1/2. Make sure you can get that. 1/2. So the similarity ratio 1/2. And then 2 circles now. 128 pi over 18 pi. And I want to know the similarity ratio. Still do what? Still want to do what to get to the similarity ratio given the area? 22, given the area, what can I still do? Square root. Go ahead, type that into your calculator now. Pi's are going to cancel, so you can put the pi's in there or not. It's up to you. What do you got for me? 15? Just a quick, not a challenge, but a think about type question. Similarity ratio, that's the ratio of 2 sides, right? This is a circle. Circle doesn't have sides. So what could this be the ratio of if circle doesn't have sides? Radii is diameters. Yep. Okay. Chords. All right. That's what it would be since circles don't have sides. The ratio of radii and diameters. All right. Let's wrap this sucker up. The shorter sides of a rectangle are 6 feet. Similar rectangle, not. All right. I always like the little diagram action, right? I got a bigger rectangle and a tiny rectangle. I got 6 feet on one. I got 9-footer on the other. The area of the smaller one is 48 square feet. What's the area of the big dog? Here's what you kids are going to try to do to me. You're going to say 6 over 9, the sides, right? That's equal to 48 over x. And everything we've done today means nothing. What's the 48? So you're telling me right now the similarity and the areas are always equal? Yes? No? No, that's garbage. This is garbage right here. Garbage. How do you make it nice garbage? How do you clean it up? Square what? There you go. You can't just set the sides equal to the area. You got to square the sides first before you set it equal to the area. Okay? Got to square the sides first. Now we got something we can solve. Sides and area never equal to each other. Square the sides. $16, let me know when you're ready. Find the area of the big one. Finish it. 108 feet. There we go. Area. Everyone all good before we get to Bonita to finish this off today? All right, Bonita. some crops. Any idea what she plants? What is it? Beans? Avocados? Sunflowers? Is that a crop? Okay. 2 rectangular fields. What do you? Each with lengths in a ratio of 2 to 3. All right. Each with side lengths in a ratio of 2 to 3. Each dimension of the larger field. You know what? I'm not a big fan of this one. Each dimension of the larger field is 3.5 times the dimension of the smaller field. I'm not a big fan of this. Get rid of it. Yeah, I'm not a big fan of this. Get rid of it. All right, get rid of this one. Sorry about that. We got to change that up for next year. Okay. Not asking for a lot tonight. Not asking for a lot. We get out of here at 35, so.